processing. So this is a new age specializations coming in electronics and communication engineering. And we have an industry veteran by name Mr. Pankaj Bande. He is the Chief Technology Officer at WIZKLUB and the former Senior Architect IoT Solutions Engineering at Wipro. Then between 6:50 and 7:10, we would move on to the careers in mechanical engineering, again with the new age specializations. And this time we would like to present to you the specializations on robotics and automation, additive manufacturing, electrical and hybrid vehicles. For this, we have the speaker, Dr. Vinayak Hemdri. He is the chairman and for Department of Mechanical Engineering and is a PhD from IIIT Delhi. And also would like to introduce Dr. M.S. Rajamurthy. He is the chief scientist and he's retired from National Aerospace Laboratories, Bangalore. And he would be touching upon the careers in aerospace engineering. So we have a good 1.5 hours of super interaction, complete guidance to the students on how you should look at the specialized programs, what are the benefits, what are the job opportunities, how does the industry look at you when you look up at these careers and the execution from Dayanand Sagar University. So before we move on to the speakers, I'd like to take the opportunity of inviting our Honorable Vice Chancellor, Dr. K.N.B. Murthy, to for his opening remarks. Over to you, sir.
Thank you, Shindik. Respected co-panelists, his students and the parents who have joined this webinar on a Friday evening. The purpose of this webinar come Campus Info session is to provide you the inputs for making an informed decision with regard to the higher study pursuits of the students. We have been doing this in the last 2 months to various aspirants, and many of them have benefited from whatever the inputs that have been provided to make an informed choice. Let me briefly touch upon what you need to consider before you exactly choose the program of study and the institute or the university where you're going to do that. The first aspect which you need to consider is the future of work. What the future work environment is going to be, what kind of skills are required, and what is the kind of preparation required for having a successful career in an environment like that. Please remember, you're going to join a program of study this year, going to graduate 4 years down the line. Therefore, you need to understand what will be the work environment in 2025. That's exactly what you need to understand. That's the first aspect. The second aspect you need to consider is what is the career that you're planning for? What is your career choice? You need to make a list of all the career choices, then start looking at the kind of program of study. That's the next aspect which you need to consider. Which program of study would give you the career that you have in mind? That's a third aspect. The fourth aspect is which university or which institute to choose for studying that program of study, lead you to that career path, and to be successful in an environment which is going to be there 4 years down the line. Let me briefly touch upon each of these aspects in the next 5 to 6 minutes. The first one is the future of work. It's been predicted that the future of work will be disrupted by the technology evolution, meaning every aspect of every work will have some technology intervention or technology being used. Therefore, you need to be aware what kind of technologies are going to dominate the future. That's one thing you need to do. Second, the current job roles, the current job titles will be far different from the job titles and the job roles of the future. That's the second thing that you need to remember. The third aspect you need to remember is the kind of skills required to handle that work environment are more or less defined. Therefore, you need to have those skills. What are those skills? A good communication, a good critical thinking ability, then a collaborative activity means how do you contribute in a team. Contributing in a team basically means you need to individually contribute and also you need to contribute as a team. That's a thing. The last one is creative thinking or creative ability, meaning you need to solve a problem or you need to solve a project or issue in a different way. How different you are going to be, how your solutions going to be different is going to be critical. That's exactly what is being looked at. Therefore, to handle this kind of a situation, what are required? Three things are required for you to handle this kind of situation. One, you need to nurture your curiosity of learning. Means the way you learn things must be nurtured quite well. That's one of the important. You don't have to change your style of learning. All that you need to do is nurture it well to suit the requirement. That's one thing you need to do. Second, you need to develop the program passion for the program study. Means you need to like the subject that you're going to study. Means suppose you're taking a program study, you must like that. You must appreciate that. You must deeply involved in this kind of thing. That's the second thing required. The third one is develop the attitude of spirit of inquiry, means asking the right question on a topic. Means that's critical to handle a situation of the future. And keeping this in mind, you need to go for what are called the career aspects. What are the career paths? There are multiple career paths possible. One, a job in the industry. That's one career path that you can think of. The second career path that you can think of is a administrative service, a government service, where you want to be an administrative cadre. Again, you need to plan what is the kind of preparation required for that. Or you can be a researcher for life because your style of working, your style of learning, your style of understanding things leads you to career path. Please remember, in the bachelor's degree, you have to decide the 4-year time is going to be critical for you to decide what suits your I should say ability to lead to a career path. The other thing that you also look at the career path is social service. Social service are the thing which you can look at. To do a social service, what are the kind of things that you need to do? That's the other career path. Any one of them, each one of them are good. Please remember, every job career path is excellent, provided you like that particular path, you are prepared for that kind of career path. The other thing that you also need to understand is the future gives you plenty of opportunities. Opportunities are going to be doubled in the future. It's been predicted, though the job roles are going to be automated to a large extent, the existing job roles, but the new job roles are going to be created that are going to be available in plenty for those people who have the abilities, which I mentioned a few minutes back. The third aspect you need to consider is the program study. Which program study? And please remember, every program study is equally good. There are lots of programs of studies. If you consider engineering, computer science and computer science related, there's a lot of new age specializations which are coming like AI, machine learning, data science, cybersecurity, etc., etc. Then you have electronics and communication, mechanical engineering, then aerospace, plenty, civil engineering, electrical engineering, etc. When you look at the program study, each program study has plenty of job opportunities. Please remember, every program study has opportunities. Why I'm trying to tell this? I'm trying to tell this with confidence that the future requires a lot of the work, technological innovations. One, to provide clean and potable water. To provide clean and potable water, obviously chemical engineering is involved, the computer science is involved, electronics is involved, mechanical is involved, everything is involved. If you look at the universal healthcare, when you say healthcare, not only computer science, the biotechnology is going to play a role, then electronics is going to play a role because the instrumentation is going to be critical. Then mechanical engineering is required to build those the healthcare devices. I think please understand all the branches of engineering have a role to play in everything that's going to be created. Then look at the other kind of opportunities, the plenty of opportunities like public safety and the national security. Every branch of engineering is involved in each one of them. Safe and speedy mobility. When you think of speedy mobility, obviously, if you look at aircraft to have the speedy travel from one place to other place, I think the aerospace engineering is going to play a major role. Then mechanical engineering is going to play a major role. Therefore, please understand the branch of engineering, the program of study is going to be critical. You choose any one of them. Again, make a list of computer science first preference, mechanical engineering second preference, electronics third preference, whatever. You make a list of all the things. Now you have consider all the three aspects. The most important thing that you need to decide now, do you have the talent for that program study? Because you choose computer science, you need to have good mathematical background. You need to have good reasoning, good logical analysis. This is what is required. Therefore, you need to audit whether you have those skills. Suppose you like mechanical engineering quite well, you can do a mechanical engineering, then also do something else apart from mechanical engineering because you like that course. Then the last thing is which university to study this program study. And any university which has understood the future of work, any university which has designed that curriculum to meet these requirements is the university to look for. You need to look at not the buildings of the university. You need to look at the faculty of the university. If the faculty are really good, that faculty will give you the kind of skills required, prepare you for the future. I sincerely request each one of you to take note of all these things and choose that university which gives you the right teaching learning environment, the right assessment kind of things, and right opportunity for the career path, and to face that future of work and that future work environment very confidently. I wish each one of you best of luck and thank the organizers for giving me this opportunity to be with all of you this evening. Thank you. Thank you very much.
Thank you so much, sir. It's always a pleasure to listen to your guidance and the advice given to the students. I would now like to invite Professor Dr. Viraj Kumar, sir, to please take over and give the presentation on the specialized computer science engineering programs. Over to you, sir.
Thank you. Can I start off, Shinde, after which Viraj can come?
Yeah, because I think sir had some hard time. If he's okay with it, then it's fine.
Sure.
Yeah. Arvind, if you don't mind, I'll go. I have to.
Yeah, please. Sure.
Okay. I hope my screen is visible, everybody.
Yes, sir.
Okay, I'm keeping my video off because in the interest of bandwidth, I don't want it to lag. All right, so I'll talk a little bit about CS programs in general, and then the specializations, especially the ones that we have at Dayanand Sagar University. Okay, so let's get started. As Dr. Murthy just mentioned, we have to look at the future of work, and to a great extent, the future of work is going to be shaped by computing. And this is important whether you happen to take a CS degree and then decide you want to work somewhere else, or if you decide you want to specialize in something else, you will probably need some amount of computing. Right? So I think this is the first thing to keep in mind, that computing is going to be there as part of your professional career, one way or the other. And the only question is, do you want to specialize in computing itself, or do you want to specialize in another? So just one thing to keep in mind, even if you're not immediately pursuing a computer science degree, please do look out for all opportunities to leverage computing, because they're going to be there in your professional career. Whether you should take the general CS program or should you specialize, I have some suggestions for you. Right? So, there are many specializations, and there are a lot of, buzzwords, a lot of chatter around these things. So ask yourself, do you have a sense of these specializations beyond just the buzzwords? And if the answer is no, my suggestion is then don't consider specializing at this point. There will be plenty of opportunities to specialize later. Here is one reason to actually actively pursue a specialization right now, and that is if you have got yourself involved. So this is immediately evidence to yourself that this area excites you. So perhaps you have done some small project. You may even have taken some course. Right? If that's the case, then definitely you are, interested in this, and you should consider specializing. Now, of course, there are other options beyond these. You may be interested, but you haven't actually done a course, and you do understand beyond the buzzwords. Right? In which case, there is this gray area in between. My point here is that this is not the most important decision that you should make right now. Perhaps there's some clear guidelines in terms of where you should go. But even if you choose to go one way, if you choose to specialize or you choose not to specialize, what's much, much more important is that you get your fundamentals clear. And this is a point that the Vice Chancellor just made. I will just reiterate this with a quote from an industry report that came out a couple of years ago, which has some very, very, disheartening statistics. Disheartening is their word. They talk about how 80% of engineers are not employable today. So if you get your fundamentals clear, you are going to be in that 20% minority who are employable. This is much, much more important. This is why Dr. Murthy just mentioned that the place that you should be looking at is a place not which has the most glitzy buildings and so on, but where you can get your fundamentals absolutely clear. This is much, much more important. This report is echoing exactly this point. All right. So let me talk a little bit about what life as a computer scientist is going to be like, your professional life. So, underlying this profession are the 4 supers, I like to call them, of computing hardware. And as you can see in the list, I've only got 3 for now. That's because pretty much any computing curriculum you look at will take into account these 3 things, because these are trends that have been going on for the last several decades. Computers, we know in some way we have learned that they are super dumb. They can only do these very, very simple type of operations. But what makes them appear, incredible is because they can do these super dumb operations just really, really fast. Right? And we've heard of things like Moore's law, where the cost of this technology is going down. The cost of computing is going down. One thing I would encourage all of you to look out for when you're shopping around for an appropriate program, see if the curriculum goes beyond just these 3 supers. And the 4th super that is quickly emerging is that they're super specialized. Hardware is super specialized. So one of the things that you will almost certainly leverage one way or the other as a computer scientist in your professional career is not just the incredible power of the CPU, a host of other devices that are specialized hardware that is connected to this. So, as I said, these are some things you should look out for when you're looking at a particular program. So, suppose you do decide to go into computer science, you have your 4-year degree. What does life look like after that? Right? So, the first thing you will be doing pretty much on a daily basis, because you are a computing professional, you will be part of a team where you will be one of the few people who is capable of leveraging this immense power. So your role in that team will be to solve the problems using the power of computing. Right? But it's very, very important to remember, we were talking earlier about the future of work. Because these things are so powerful, one of the very interesting things that is happening is that more and more people are in a position to harness the power of computing. Right? So I'll give you a quick example. Right? This is why this field, I think, is just so exciting, because all of us have to be on our toes. We have to constantly learn. So I was involved in a project where we were developing an app for a project that has to do with archaeology. Right? They needed an app. And one of the things I told my students is, okay, I know you guys can develop an Android app. That's the technology that the project originally asked for. But what I want you guys to do is I want you to take a look at some of these no-code platforms. Right? So AppSheet is one of the technologies that are available to rapidly develop apps, even if you don't really know very much programming. And I wanted my CS students to be aware of the fact that these kinds of sophisticated apps can today be developed by people who don't have a computer science degree. It is something for them to be aware of, that they may no longer be in such a niche position a few years down. So it will force you, this domain will force you to constantly learn, to stay ahead of this rapidly maturing technology. The third thing that life as a computer scientist will give you is a wonderful global community to be part of. Right? So you've all heard of open source software, which people can contribute to. In fact, this is a wonderful way to showcase your talent. Right? There are online discussion forums. You have probably heard Stack Overflow, amongst others, where even the ability to ask a novel question reflects your understanding. I tell this to my students all the time. Okay, you need to be really good to be able to answer a question on Stack. If you can ask a question that has not yet been asked before on Stack Overflow, it means you've really understood your domain. I think that's an excellent marker of your depth of understanding, just the ability to ask a good question. And as you interact in this online community, some people, in fact, many people have translated this goodwill that you get, this kudos, into actually financial gain. So you can get a really good job because you are an ace developer in an online community, for example. So this is what some of the professional working environment as a computer scientist will look like. Very few areas have this particular combination. But this is something that excites you. This is perhaps the most compelling reason I can think of for being involved in this domain. Now, you may get the feeling that it's just programming, and maybe you feel, oh God, this is something I don't want to do. Maybe it's something that excites you. But I also want to share with you that it's not just about programming. As I said at the start, computing is going to be part of the DNA of pretty much every other discipline. And there are specific areas within computer science where we explicitly reach out to some of these other domains. In some sense, they're part of computing because computing is such an essential part. So I'll give just 3 examples. There are many here. It's a long list. I'm just going to pick 3 examples here. So the first one is human-computer interaction. So here is a project that actually Microsoft Research did a few years ago. So this is a screenshot from that project. And these are school kids, and they're interacting with a computer. Right? So this is human-computer interaction. And what they're holding up is printed pieces of paper. And as you can see on those pieces of paper, they're giant QR codes. And what these school kids are doing is they're answering their teacher's question. The teacher has asked a question, a multiple choice question, and is the answer A, B, C, or D. And depending on how the student is holding up his or her sheet, a webcam is actually reading these QR codes and figuring out what they're answering. So a low-cost technology that enables kids to interact with computers and therefore give immediate feedback to their teacher who can help them understand their misconceptions. I thought it was a nice example. Scientific computing, anytime you're dealing with any kind of science experiment or engineering project, you need this. And here's an example from, 20 years ago, but it's a famous example where 28 people died and over 100 were injured simply because in a computer, you cannot represent certain fractions exactly. So even 1/10, right, 0.1, you cannot represent that precisely. So according to a computer, 1/10 is not the same as 0.1. There's a slight error, and because of that slight error, there was a miscalculation as a result of which this is during the first Iraq war. If you're interested, you can look up Patriot missiles, and 28 people died because of a slight error. So where lives matter, where very expensive equipment matters, there's a specific branch of computing where you look at some of these issues. My own PhD was in theoretical computer science, and many people say that's really boring because we deal with issues about efficiency and computability, but they can also be super interesting. So here's a graph from Facebook's energy consumption in gigawatt hours over the last few years. As you can see, that number is going up hugely. I happen to have a chance to go visit Facebook in 2011. And one of the things I realized was the engineers there are deeply interested in designing efficient algorithms, power efficient algorithms, because they have such a huge energy bill. And of course, they were worried about that huge energy bill at that time, and now their energy bill is much, much more. Long story behind this graph. So these numbers are very big, despite the fact that Facebook, amongst other companies, hires very, very brilliant people to design very, very efficient algorithms to keep this number down. Even so, the power demand in a company like Facebook is just so enormous. Something to keep in mind next time you log into Facebook. All right, let me just talk a little bit about these domains now, rather than just general CS. So I'll take you just a bit beyond the buzzwords. Of course, there's much more to say about each of these domains. So the most exciting one, perhaps, is AI, and the overall goal is to mimic human intelligence. And given everything I've told you about the power of computers, they will certainly surpass humans if they're able to get to the point where they can mimic us successfully. So that's the goal. And I gave you actually an example of an AI system. When I gave you this, this decision-making process last time on the first slide, this was an example of, in the earlier versions of AI, they use this all the time. These are all expert systems, rule-based systems. So some expert, maybe if you think I'm an expert, is writing down the rules for how to make a complicated decision. In this case, whether you should specialize or not, or maybe there's a gray area. You take that expert and you convert their gyan, their knowledge, into some kind of rules. And the most exciting thing about this current machine learning revolution, which is just one of the many approaches towards AI, is maybe we can get rid of the expert. Maybe if we had enough data, we could figure out the rules from the data. And that's a very nice idea. And the whole explosion in deep learning has been just demonstrating that this works actually really, really well. But it has a whole host of other issues that have come about. And so these are some of the issues that increasingly a good program will expose you to. Right? Issues of fairness, accountability, transparency, but perhaps most importantly, ethics. Right? And I'll give just one example of the kinds of ethical dilemmas that come about when you try and use any technology. It doesn't have to be AI, but just one example, since it's easy to find such examples in the news. So this is just from a few months ago. Japan decided to fund AI matchmaking. You may be well aware that Japan has a demographic crisis. They have a large number of old people. They want to replenish their population, and so they want to say, can we use AI to facilitate matchmaking and then maybe boost the birth rate of the country? And this was a decision that an appropriate team of experts looked at from the technological perspective, the legal perspective, the ethical perspective as well. Should they do this? Now, here's a question for you to think about. 4 years down the line, maybe 5 years down the line, maybe 10 years down the line, after you graduate with the requisite skills, imagine you are on a committee because your country has decided to use AI matchmaking. And maybe this time they want to do, not to boost birth rate, but maybe lower birth rate, because we also have a demographic crisis. This is a thought experiment. I'm not saying this is going to happen, but you may be able to do this. Should you do it? That is the ethical question. And one of the things that you should look out for when you're selecting a degree is not just a program that will provide you the necessary technical skills, because that is, of course, important. Also, some of these other increasingly important issues related to the use of the technology. Should you do it? Is it correct to do this? Let me talk a little bit about data science. So again, the overall goal is to improve decision making, and we want to somehow use all the data that we have. We have lots of data, and we have all these super powerful computers, and so exciting, can we do something amazing with the combination? And so there's a lot of effort in these programs, and if you take a data science program, you will spend a lot of your time developing these skills to process a large volume of data. Right? But it's very, very important to remember that it's not volume. Right? It's not actually the data that's the most exciting word here in data science. It's the science. Right? Because if you have bad models, bad basis for what is going on in your data, just adding more data is not going to help you make better decisions. So this is a very nice example. I will share this. If you're interested, you can look up Wikipedia a little bit more for Simpson's paradox. But they have this nice GIF that shows what we're talking about. So this is cloud of data points. Right? And if you didn't know anything about the population, if you didn't know anything about the science behind this data, then you might try and plot this regression line that you can see now, which is sloping downwards. And you say, as you increase the x coordinate, the value on the y coordinate goes down. So whatever this x represents, the more we have of x, the smaller y becomes. Whereas what this paradox is trying to show is actually, if you knew something about your data, you might know that the population is actually all these subclusters, different colors, and within each subcluster, the regression line is actually going up. Right? So simply having more data is not going to help you realize this. You have to know about your domain. And this is why we say the keyword is not just data. I'll close with a brief look at cybersecurity. So here again, the overall goal is we want to protect whatever assets we have, servers, and data, and so on. We want to protect it from digital attacks and, of course, recover from those attacks as and when they happen. Right? So this is an arms race, and maybe this is something that excites you, maybe this is something that terrifies you, but this is what this domain is all about. It's preparing you to hopefully be the good guys in this arms race. Right? In fact, many people are in this sort of gray zone where they want to use their skills to actually do hacking. Right? So I'll give you an example because I don't want to make it too technical, but again, if you're interested, there's lots of examples that are actually accessible to all of us. All of us have to grapple with these issues as members of the 21st century. So I'll just share one example. Okay, so this is actually a screenshot from this YouTube personality. You may have heard of him. His name is Kit Boga. That's a fake name that he goes by. He actually trained as a computer scientist. But then he's decided that he wants to spend his time doing this particular stuff on YouTube, which you see, and he also has a Twitch community that he's part of. Here he's talking about some of the things I said earlier. How being part of this community can teach you a lot if you're interested. So what he's doing here, he's actually developed an AI bot. He's used some open AI system to create a bot that can talk to scammers. There's unfortunately a large number of scammers who come from our country. And what he's doing here is, he's got this AI bot that is talking to a scammer, hoping to waste the scammer's time rather than, cheating people out of money. So this is one of the things he's doing. He's using his computer science skills to do this. Now, in cybersecurity, you're dealing with much more sophisticated opponents than some of these scammers. Many of them don't know the first thing about the technology domain. But here the interesting thing is that this person wants to develop this AI bot so that he doesn't have to waste any human being's time. The AI bot can automatically call these agents and drive this particular unethical and illegal business practice out of existence. So the weak link in general in cybersecurity is human beings. And so one of the things that you will learn in such a program beyond the technology is policies around how to make sure that human beings don't make bad decisions, because we have a tendency to do this and we tend to be the weak link. Even when we know that these issues exist, I'm sure at least some of you would have heard of someone in your social network who has succumbed to some scams like this. There's so many of these online. All of us have to be aware. And this is just, as I said, the sort of one tip of a wide range of issues around cybersecurity. This is what you will get exposure to through a specialization. Okay, I'll close here with just this one quote, which again reiterates the points I was making here. It's a longish quote, so I won't ask you to read it. But the essential point is that there are many of these domain skills, even, not just the general skills, but even the domain skills, which hardly any graduates are developing. In fact, what many institutions are trying to do is at least ensure the basis, the fundamental programming skills. What this report is complaining about is that if India wants to progress, then of course we need graduates who have the basics. You cannot progress beyond the basics, but then beyond the basics, there are many, many more things that interested, if you're motivated, this is going to take hard work, but if you do it well, you are going to be in this very small minority. These numbers, the percentage numbers that are here on the slide, just give you an indication of how small the eventual pool of highly skilled engineers is. To be part of that community. I wish you all the best. Thanks.
Thank you, sir. Thank you so much. Now I'd like to invite Professor Arvind Srinivas, sir, to take over.
Thank you, Shinde. Just give me a minute. I'll begin sharing my screen. I hope my screen is visible.
Yes, sir.
Yeah, thank you. Yeah, first of all, welcome to all the panelists, the Honorable Vice Chancellor, and also the industry professionals who are part of this panel, and not to speak of the parents and students who are anxiously waiting to find out what is it that they have in store from this webinar. I'll be talking a little bit about the School of Engineering from the Dayanand Sagar College of Engineering. A little bit about the School of Engineering, and try to tell you about what the differentiator in Dayanand Sagar University, and a little bit about computer science, because Viraj, my colleague, did speak a little about the different aspects of computer science, but I'll just take a step back and cover a little holistically about what DSU is all about. First, about Dayanand Sagar University itself. I mean, this was the Mahatma Gandhi Vidyapitha Trust, which was set up in 1962. And Dayanand Sagar University is one of the universities under that. And as you can see, there are about six colleges, in fact, 7 schools under the Dayanand Sagar University. What we are talking about right now is a School of Engineering. There are other schools also, like Health Sciences, Medical College, Arts, Humanities, Commerce, and so many other things. It's a state private university in Karnataka. So with this in mind, I just wanted to give you the context and then quickly move on to the fact that we are actually getting into what exactly is engineering and what is it that is in store for you in Dayanand Sagar College. So you can see these 3 vegetables over here. One on the left-hand side is the cauliflower, which probably some of you may like, especially Gobi Manchurians and all that. The one in the middle is nothing but your cabbage, and the one on the extreme right is what is popularly known as broccoli. These are all known as cruciferous vegetables. That's something very common between all of them, primarily because they are basically having 4-petal flowers, which is common across all of them. And all of them are low calorie, very rich in folate and vitamins C, vitamin K, and vitamin E, and fiber, which was discovered over a period of time. So very similar to that, in a similar analogy, I just want to bring something which is very common across the branches, what we have got to offer here. You can see mechanical engineering and aerospace, which has got the 2 major branches currently offered here, where we've got drawing and a few other things which are common. Then you have the electronics and computer engineering and computer science and other related areas, because there are several related areas. 3 of them, Dr. Viraj Kumar spoke about: artificial intelligence, ML, cybersecurity, and data sciences. And one of the most important things here, what is common as a subject, apart from your standard physics, chemistry, Professor Murthy already spoke about mathematics being common interest. But given the fact that the world of IT is touching every other vertical, whether it be commerce, science, or engineering, there is no difference between the way IT touches mechanical engineering or aerospace or ECE itself. So there are certain common areas like algorithms, data analytics, and artificial intelligence aspects in the context of aerospace and mechanical, as the case may be, though it won't probably be as detailed as what it is, but definitely you will have an opportunity to get a touch and feel of what exactly happens in all these fields. So primarily you learn what is called problem solving using the principles of mathematics, science, and applying them to algorithms, analysis, data analytics, statistics, a lot of statistics, and artificial intelligence, which is nothing but a little bit of a pattern making. So how do we assist you in DSU? What I would like to say is just people are happy when they tap into their passion, play to your strengths and likings, and celebrate your success, no matter whether they're big or small. So just develop a passion for your program of study. As the Honorable Vice Chancellor mentioned, decide on what makes you follow something, check something, and then have the passion for something. What is it that interests you most? The other aspect is what you see here in DSU, the heuristics of learning and the spirit of inquiry. We did touch about it earlier. Heuristics are nothing but simple, efficient rules which are learned by evolutionary processes that have been proposed to explain how people make decisions, come to judgments, and solve problems, typically when faced with complex problems or maybe with complete information. I'll just give you a few examples. Examples of this method is something what we call as the rule of thumb, an educated guess or an intuitive judgment or a guess estimate or common sense is sometimes what we call in daily life. Someone who follows a recipe from memory in cooking, for example, they know how much of salt and pepper and all those things to be putting in. There's a very quick bit distribution that's evolved over a period of time because your mom or sister or who is cooking is using a heuristic without actually using all those specific calories or grams or weights and all that. That's nothing but a heuristic. A lot of aphorisms such as measured twice, cut once, and things like that are part of heuristics. Or a sweeter old woman might remind you of your grandmother, so she might immediately assume that person is kind, gentle, and trustworthy. People are more likely to see decisions as having higher benefits and low risks when they are in a positive mood. So this is typically what happens in terms of the heuristics of learning. And the next one is in terms of synthesizing connections across different areas. What you see here is not an IKEA store, either in Bangalore or Hyderabad or anywhere. It's more related to the synthesizing is nothing but a combination of information from multiple sources to form conclusions, connections, and then act upon it. Synthesizing is trying to put things together, as you can see here, with a model aeroplane or a small chair, which has actually come across. So this is typically how DSU is assisting you. Let's also look into a little more depth on how we can assist you. The first one, Professor Murthy did talk about the curiosity, creating value, and connections, the 3 C's. Have you looked into your own backyard in terms of trying to find out if you have a small internet-based device, maybe the bulb or something like that, which is available with you? Have you ever tried to figure it out? Or how is it that you are able to create value based on what you've discovered? And have you tried to connect certain things in like what Dr. Viraj Kumar talked about, trying to connect the basic fundamental principles and trying to see connections between all of them? Or cross-cultural things. Cross-cultural competency is something which you develop here, primarily because it refers to your ability to understand people from different cultures and engage them effectively. Culture is the result of language, regional customs, religion, family traditions, etc. Having a cross-cultural competence means that you can be effective in your interactions with people from most other cultures. That's the beauty of India as well. Design mindset is something else which you also help you. A design mindset is something which is more of solution focused and not merely problem focused and action oriented. It's more related to actions. It involves both analysis and imagination. Examples are the Apple's user experience with the Apple iPhone, or the rise of online video streaming, which has now reached new heights with players like Netflix, Amazon Prime leading the scene. But even a decade back, satellite independent entertainment was an obscure idea. Design thinking is the core of any disruptive innovation. Look at how the Red Bus, which is an aggregator, simplified the bus booking from students when they had to travel late night in Bangalore, especially. I still remember those days in Anandaratharka or go to Majestic, and I decided off the cuff just to say that, look, I want to go back to my native place. Or focusing on minimalism, which is the well-being and sustainability. We're bringing out certain watches, which you must have seen from a company called Fossil, or probably the track TRAQ from Titan. The transdisciplinary competency is another thing which also help you develop. It's basically an art of learning, which is exploring a relevant concept, issue, or a problem that dissolves boundaries between conventional disciplines and organizes teaching and learning around the construction of meaning in the context of real-world problems. We use concepts like storytelling, negotiation, influencing to do interdisciplinary connect. What does it mean to be a historian, a biologist, a mathematician, and a linguist all together put together? Fostering collaboration between different schools is what you learn in DSU. Sense making is another competency which you develop here. It's the process by which people are giving meaning to their collective experience. The last thing a teacher needs to give to pupils, to students, is more information. Nowadays, with Google and several things and Wikipedia, there are several things which are correct and several things which are wrong. So the students already have too much of it. Instead, what they need is the ability to make a sense of the information available, to tell the difference between what is correct and what is wrong, and what is important and what is unimportant. And above all, combine many bits of information into a broad picture of the world. That's exactly what sense making is all about. We proactively track the market requirements by inputs from the World Economic Forum, NASSCOM, and predict the future skills and the future work for individuals, institutions, industries, and governments to take note and act. That's what we try to do here. And all of this obviously results in future job requirements being made ready, maybe 4 years down the line before you even start thinking of what you're likely to be working on. There is also a provision for learning and securing academic credits by working in an innovation lab, which you can see some very well-known names here with the GE, IBM, Autodesk. And this is just a few set of illustrative examples which you can see over here. And this is something which is very different from DSU, from the rest of the private universities. We offer what is called as a minor specialization and honors degree. Minor degree is something what we call as a securing an additional 18 to 20 credits outside the area of a department. Let's say that you are a mechanical student, but you also are interested in computer science. Then you can take a major in mechanical engineering and do a minor in computer science. Or you're already interested in computer science, but then you also want a little bit of management because you believe that you have the ability to supervise. Then there is also an MBA department here where you can do a major in computer science and a minor in management. I'm just giving you examples there. Or specialization. Specialization is nothing but securing an additional 18 to 20 credits, the same department what you have, to enable your master's degree or further employment. Like for example, in mechanical engineering, thermal engineering, you can do mechatronics, computer science with cybersecurity, or aerospace and aerodynamics. I'll show you a little graphics later. And honors. Honors is something which is highly specialized within the degree, where you secure an additional 18 to 20 credits in the same department, but through open educational sources such as OCW, SWAYAM, NPTEL, Coursera, EDX, and thereby enabling employment. So this is something very unique which we offer. So you don't have to necessarily rush towards computer science because you have an attitude in mechanical or electronics or aerospace. You can always do whatever you, as I said earlier, just follow your passion, but you have the ability to also add on certain additional things as you go along. It may be difficult for you to start with when you come into the first year, but then as you go along, you may discover certain more interests which are likely to impact you. And then you could always take up any minor courses as you go along. So just a quick graphic in terms of the specialization, which I talked about earlier, in terms of securing additional 18 to 20 credits in the same department to enable your master's employment. This is aeronautics with a specialization in avionics. This is nothing but the flight decoder, what you can see on the screen. There are certain courses which could probably help you to specialize in that. Or probably Viraj talked about the computer science with specialization in ML. What you see here is primarily trying to distinguish between a dog and a cat, and then the input, the hidden algorithms and all of that. We finally realize that this is nothing but a dog. And this is actually taken from Carnegie Mellon. I acknowledge them, as you can see here, on machine learning. Or probably if you want to specialize in mechanical, especially the current Olympics and the Paralympics and all that, there's a lot of opportunities with specialization in biomechanics. As you can see, the gait cycle as people walk along. Just a small sample to illustrate you what is in store for you when you take a certain minor or major degrees as you go along. Also, one other aspect is very quickly to cover about broad aspects of assessments, which you have definitely university exam 40%, but the 60% is what actually excites you most in terms of assessment. The beauty here is you can see here in this cycle over here, there are 10 different types of channels. You can attend a quiz, seminar, or you can attend a webinar or something like this and make a reflection notes, give a project demo or an open book assignment, the boot camps, poster presentations, several things are available for you. You can pick and choose and figure out how you want to constitute that 60% based on the consensus between you and the faculty. And the rest of it is your 40% as the end semester exam. So primarily you can submit all your assignments through online or short video in this current pandemic, as you can see. So we are primarily trying to be fostering your creativity as you go along. But at the same time, we are very compliant with whatever norms the university has given and also within the norms of the UGC. And we also have right control, as you can see over here, when the admission exams are being available, even at a home proctored exam, where a lot of control is available on the way you conduct your own entrance exams. So this is last few slides about the placement outcomes, which is probably something which most of you are interested in. Being an emerging university, I'm showing you the last 3 years. We have had more than 190 odd companies and 248 companies going up. And the placement is pretty much close to about 80%, 85%, as you can see. And there is a lot of student participation, which has also significantly improved in external improvement and external events conducted by either the academia or the industry or whatever. As you can see, the number of enrollments has doubled in the last couple of years. So just to conclude on, though I'm from computer science, I'm trying to talk about computer science being the ability to harness the laws of physics, mathematics, and the models to create aspects of computing and society. And in this, every student goes through the foundation courses in science, humanity, and engineering. So these are the three specializations which my colleague Dr. Viraj spoke about. At the top is what I call artificial intelligence and machine learning. At the left-hand bottom is the data sciences. And on the right-hand side is the cybersecurity, where you have either the ability to become ethical hacker, or you can become information security professional, or whatever. The careers are definitely available. So with this in mind, I wanted to conclude and thank you, and wish you all the best in whatever career you choose and whichever program or specialization you say. Thank you, Shinde.
Thank you so much, sir. Thank you so much. Wonderful information to all the students in terms of choosing the specializations, looking at a career in specialized based engineering programs, more say in terms of the computer science engineering. Thank you so much. We now move on to invite Mr. Pankaj Bande, and he will be talking about the areas, the careers, the opportunities, the new innovations in the electronics and communication space. Over to you, sir.
Thank you, sir. Am I audible?
Very much, sir.
Yeah, thank you. So good evening, everyone. So I'm Pankaj, and I work as a Chief Technology Officer for one of the tech startups, that is WIZKLUB. And I have my bachelor's and master's in electronics engineering. And it has been 20 years for me, rather than 21 years almost in the industry, plus academics, a mix of it. And the very reason I'm here is because I wanted to share my thoughts that all of you who are the parents and the students who are trying to get into engineering, that because I run a startup and I have a team of engineers and people from other disciplines also who work for me, around about 60 plus people actually work for me, and they are from various domain expertise and all that. How does it work for me as a company CTO? And what I expect as a person, if I have to look at you as a prospect candidate whom I will interview and offer maybe a 12 lakh package, and ask you to join my company, and also share that we do interesting work. It's not about the package, it's not about it's not about what I do, but it's about what I do, what you like, and then the package. All of these points, if we try to tick mark, and if it works for both sides, a person actually becomes part of the WIZKLUB'S innovation product design team. So essentially there are a lot of things which are involved when you look at yourself as a candidate in a company. And nowadays we do not just look at someone who has completed his engineering with a lot of percentage, but a complete package. Let us take an example, that if we take the example of Virat Kohli, he is obviously the greatest of the guys who is leading in the world of cricket, but at the same time he's a fitness freak, he's a great actor, and he's a good communicator. A lot of things are expected. What if he just ends up playing good cricket, and he doesn't have all these other things? A good fielder, a great fielder rather, right? A fitness freak, so that he can consistently play. So whenever you actually become a complete engineer, the word complete has a lot of elements actually, and many of them are being touched by Mr. Arvind also. Professor Arvind also has a part of his talk as well. So let me actually try to show you these things in action. How does it work out? When I say in action, I'm just going to play a video, and you will see that what is the atmosphere in my office and how we work together. Is my screen visible? Can anyone please confirm?
Yes, sir.
Yeah.
Beginning to start sharing.
Yeah. So I'm just trying to play this video and just see through that what are the things which are involved actually when this video is being played. It is a 4 minutes 21 seconds video, and I will just try to play it once, and then again I will come back and try to share what goes behind the scene in terms of the roles played by various engineers in the company. So we are talking about the world's largest, biggest ambient computing setup. And you see a lot of electronic components, wires, ultrasonic sensors, displays, processors, breadboards, and a couple of guys who are now trying to put it all together and trying to create something. Then comes another guy who is trying to do something on the computer in a CAD design software, and then it goes to some sort of a laser cutting thing. Then another guy, I'm not taking the names because then I will try to bring things in picture, and it's a continuous process wherein the first two guys did something, the next two guys did something, and then it is all coming together. So it looks like a setup with a lot of electronic components and a kind of effort. And then suddenly we come to a website which says online, 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 the word. And then there is a connect of this hardware which is brought into life by connecting it to internet. Then we move on to another version of the same setup which we have created, is a PCB design setup actually. So again, printed circuit boards and all these small modules is a combination of PCB design, CAD design, and all of that. So it is happening, and it is a part of our ambient computing lab. We call it as a futuristic lab. And again, you see a CAD design and laser cutting kind of part which is coming second time in this video. So again, this all gets combined and another setup is coming up. So two guys are trying to now put it together, connect the dots, and all of these guys who are trying to play their roles, what may be their background, what kind of engineering degrees they have, what kind of work they do, what kind of packages we as WIZKLUB offer to them, and look at the outcome of it, the second setup, right? Huge number of components. And then these are the thousands of the kids, I'm saying kids literally, who are now going to work together and trigger million line of code, literally a million line of code. So the code actually is executed in North Virginia and Dublin, but the hardware is in Bangalore, India. And these are some of the example kids who are part of the coding practice. And then they are trying to now program those two hardwares which you are able to see. And then they are able to build chatbots and Alexa skills for that hardware. And now the hardware will start responding. So you will see that once the skill is built, the hardware will start responding. So you talk to this hardware and the hardware starts responding. So I'm just trying to show you a continuous journey of a lot of things which are happening. And the kids are involved, there is a front end involved, there is programming languages you are able to see now. We moved from Blockly to Alexa skills to chatbot to Python. Now we are going about web apps, which is about HTML, CSS, and JavaScript. So for me as a company, none of the branch matters individually. All it matters is how these branches come together and work seamlessly so that, I as a company person, CTO, can run my operations with the help of all the engineers who are part and parcel of my team. So this is machine learning part of it now coming. And then the technical stack. So this is where the entire technology components which are working behind the scene, whatever you saw, and then the architecture, what is behind the scene, is again coming into play. So this is how the interconnected components are there in that. And almost all the branches of engineering and beyond engineering also comes. And how many exact number of files, how many exact lines of code, and around 20 programming languages, all of this works together to make this happen. And this is what is the outcome, the two lab setups of PCB designing and the breadboarded setup. So all of this, which I just demonstrated, I initially mentioned that I am myself an electronics engineer, and even my master's is also in electronics. But today when I'm working as a CTO of a company, if I again take you back to this video at the beginning, now I just gave you a bird's eye view of that video. I'm looking at it. I'm saying breadboard version of the world's first ambient computing cloud IoT lab setup, location Bangalore, India. So breadboards are basically used by electronics engineers to prototype circuits. Even the computer science engineers also have these subjects, and some of the mechanical branches, mechatronics branches also have subjects where they do a little bit of electronics. But when you hear the word ambient computing, which is obviously the future, that you talk to everything rather than just doing a mobile app or a web app for anything and everything. Just talk to anything and get the work done, right? So I open a Uber app, then I look for a taxi, I insert a location, then I choose a type of taxi, and all of that I do. In an ambient computing world, just talk to Uber. Hey, I want a Uber, I want to go to this location, and everything will happen. That's where the world is moving towards. So how this breadboard version of electronics connects to the ambient computing, and then we say about cloud, which has got a lot of components on the side of computations. Almost everything nowadays is trying to move towards cloud, but the entire infrastructure of cloud is basically a computational center, which is full of infinite hardware. You can say literally hundreds of thousands of computers and computational things, which are again coming back to electronics, and this assembly of it and the design of it involves civil engineering, mechanical engineering, and then we call the IoT part of it. So whatever components you saw, the electronic components are actually connected to internet. The LED, the simplest of the device, or the display, whatever you saw in that video is all connected to internet. So that's where it's all interconnected. Like, you can't just imagine an IPL match. A person hits a six, the people dance on the immediately, the music is also played, and then there is Shah Rukh Khan, because it is a KKR match, he's waving his hand in the crowd, and then the other team belongs to maybe a politician who is also trying to cheer his or her team, and then everything is happening so seamlessly, and we are able to digest that. But why not in the space of engineering? The engineering space in the real industry is a seamless interconnectivity of all branches working together. And that's what, I have seen it in Dayanand Sagar University, that they insist that, the kind of, and they give you the credits for that. That's the beautiful part, right? That when I'm becoming a computer science engineer, I must have a touch of mechanical. I must go and do some credits in other branches. And in the process, I get my credits. I also get to know the department. I also get to know, I make some friends maybe there, and I ensure that, I become a complete engineer. While I become specialized in my role, examples are that if I say that what is Rishabh Pant, a specialized wicket keeper and a batsman, but what if Jasprit Bumrah, a great pace bowler, right? So I have a specialized aid, but I must be a team player. I must be a good fielder. I must have a ability to connect to others, right? I must be able to follow my captain and bowl according to the field. So that's where these things interconnect in the real world. Same is the requirement in case of the engineering. And the only part is that it doesn't come in the form of game and sports and entertainment. This is serious, because this is about our life. This is about engineers build the world. So whatever you see, wherever you see, somewhere some of you people will become the contributors. Okay, so I move this video a little bit so we can see capacitors. So now, as I'm an electronics engineer, this is an electrolytic capacitor. It's an engineered device. Maybe theoretically it is epsilon A by D, but if you look at it, it has got a porous material inside it, paper. The paper surface of the paper is etched so that the surface area of the capacitor increases. It has got a weak link on the top and a rubber at the bottom, because if this capacitor is connected in reverse polarity, it generates 1000 degrees Celsius temperature and it explodes. What if it explodes inside your computer? What if it explodes inside your mobile phone? So then it has to leak out. So the capacitor is also an engineered device, right? A mechanical guy, electronics guy, the fundamentals, everything comes together, and you are able to see a simple component as simple as a capacitor. So my view is, if I am an electronics engineer, I know everything about capacitors because I did my degree and masters in electronics. But at the same time, I can't stop, right? I have to run the department with multiple branches coming together. And that's why I learned robotics, I learned mechanical, I learned cloud. I'm still learning. It is never ending. But what you do in these 4 years is very, very important. Okay, so I move from capacitor, I come to wires. What are the specifications of these wires? These are called as, single core wires. So the AWG, the 22 AWG is the best perfect size, which fits into the breadboard. But why different colors? Because red color indicates 5 volt, orange color is for 3.3 volt, black color is for ground, and then I use the white, the blue, and the green for input, output, and IO type signals. So I don't just choose these colors because I like them, but I choose them because I know how to design a circuit on a breadboard, how to engineer a circuit on the breadboard. So there is always a reason why I choose this. Then how do I choose the quality of the wire? When I go to market, how do I test that this is a good wire for me? Is it malleable? Is it ductile? What is the way? Because if it is brittle kind, and if you insert this wire inside the board and it remains inside, then you will, kill a lot of these breadboards, and you will see a lot of loose connections and short circuits and all that. So even choosing a wire also needs a lot of engineering knowledge behind the scene. So that's there. Then we move on and we see ultrasonic sensors. So we move from a simple what you can say a wire description to suddenly an ultrasonic sensor which is capable of sensing distance and what am I going to do it with it. So we move to the world of sensors, and then the moment this is connected to the internet, it becomes a IoT sensor. Okay, then I see OLED display, organic LED displays. So the information which I want to display is going to come on these displays actually. So how do they work? The I2C protocol which is used to connect and program, the programming language which is used to program these displays is C++. So again, there is a connect of a programming language to be able to do, and there is an understanding of a I2C inter-integrated circuit protocol also. So that comes into picture. Then I go to this. So this is basically a collection of processes, and it is in anti-static bags because they are sensitive to the voltage generated in human body. Human body can generate up to 33,000 volts basically. So how do you protect the processors, which is the most important element, the brain of your the circuit actually, whether it is a computer or a mobile phone or even the thing which I am doing here. So we put it in anti-static bags, and we ensure that we don't touch it when our body is having some static charge inside us. So that is where the processors are. These are ESP32-bit processors. And then the most important, the breadboards, right? So the breadboards are the ones. So the breadboards have how many points to connect. It is considered called as a 830 points breadboard. So there are 830 specific dots, and I will be able to put a lot of components. So I am just trying to give you a glimpse of how good I am when I see the same video and speak about it, because I am an electronics engineer. And then comes the skill. So from here we are moving to skills. So what you see on the table is wire strippers come cutters, and then there is a nose plier, and then there are these components essentially. And then this is Avinash, who is an electronics engineer, and Divya, who is an electronics engineer. Both of them have super skills when it comes to breadboarding a circuit. They do the circuits perfectly. You can also see a multimeter. So while they are designing it and assembling it and trying to engineer it, they will ensure that they are testing it at every level. There is no open circuit, there is no short circuit. A simple continuity tester on a breadboard also works out, which you learn in your electronics engineering essentially. So that is there, which is coming into play here. So they are doing this now, and then suddenly we move from their skill set to Ajib. So Ajib is a mechanical engineer in my team, and he works on here he is working on CAD design in Fusion. So Fusion is a software which the mechanical engineering students actually learn as a part of their curriculum, and here he is designing that setup, the setup which you have seen in the lab actually. So he first designed it in Fusion software, and then eventually Amar, who is the other mechanical engineer in my team, has actually taken it for laser cutting. So laser cutting that setup, which is designed in this. Now Amar is trying to assemble that laser cut setup. So these are the two things which are involved, and now Amar and Ajib are completing the assembly. And then now the two electronics engineer and the two mechanical engineer are trying to put things together. And what you see is the world's biggest ambient computing cloud IoT lab setup on breadboard. And it has got more than 1,000 components which are all connected to internet, and it has got this processor which is ESP32, which is connected to Wi-Fi also. So Wi-Fi configuration, Bluetooth configuration, everything is a part and parcel of this lab setup essentially. So till this point, what you all saw is all core part of electronics and mechanical working seamlessly together. Just imagine that I only have two electronics engineer and I don't have a mechanical engineer. How will I put this setup so systematically? Look at the exact holes which are there to which these small USB cables are connected. So it is perfectly connected, and the middle section is having all the adapters to which it powers up. Okay, so this moves on, and now suddenly a web portal. Now this is designed using HTML, CSS, JavaScript. And all the processors which you just saw are the IoT processors which are online. And it says BB, that is breadboard. Breadboard 3 CIL. So that is, this entire ambient computing lab breadboard 3 device is at present online. Some of the initial devices are offline, and you are able to interact and connect with these devices using a web portal. So that means everything is on cloud now. But this is designed in HTML, CSS, and JavaScript, and this is hosted in North Virginia where our servers are. And the IoT server is in Dublin, and the lab is in Bangalore. And this web portal can be opened by anyone, anywhere in the world, and that's where the entire connectivity is seamless. Okay, so that is there. And now this is that hardware which you just saw is coming into picture: the OLED display, the ultrasonic sensor, the servo motor, the processor, the capacitor. What is the role played by every component? If that component is loose or has gone wrong, you have to immediately troubleshoot it and put another component and understand things in real time. So this is one part of it. So that's how the entire thing is completed. And then we move on to the PCB designing. So whatever you did on the breadboard was your skill. Now you design things on PCB, which is again a printed circuit board. So you create a circuit. So I haven't shown the PCB designing process as part of this video because this is the third version of the video. The fourth version is coming up. But at the same time, what it confirms is a lot of people working together. So you will be able to see, Hari here. So Hari is a computer science engineer here who is actually, good at programming. And then there are many other guys who are good at this. Again, Ajib and Amar did the design again for CAD for this setup. And then essentially now this is Sandeep, who is a mechatronics engineer, along with Ajib is assembling the setup. And then all the interconnections of these things are done by Sandeep, who is a mechatronics engineer, basically in my team. So, all of these guys, you can always try and see that what kind of a skill set they are trying to do. And then the setup comes to life. So there is Manisha and Sitara here, who are actually computer science engineer. There's Wahida here, who is a MSc in electronics. And then there is Pranjali here, and she is a HR from in our company who has a business BBA background in HR basically. So all of them are there as a part and parcel of this team when this setup is getting completed. So these are the 3 layers, and we have perfectly engineered this. And as I said, this is the world's only cloud computing, ambient computing lab essentially. And what you see in the background are hundreds of thousands of kids across the world. K-12 kids, you guys are in 12th. We actually, provide this IoT programming to kids from first grade to 13th grade, 9th and 10th grade, and then they work out on this and how they program it. That is what is the case which we are trying to showcase here, right? So this is what, is the overall picture, that the setup is in Bangalore. This just trying to show a glimpse. The setup is in Bangalore. It connects to satellite. It goes to North Virginia where our servers are there. And then it actually goes back to Bangalore, and then Dublin, Ireland, where our IoT server is there. And then it comes back to Bangalore, either via sea cables or via satellite, or a combination of these two. And then these are the kids across the world who are trying to now program those devices. And that's where the seamless world of Internet of Things connected via cloud, consumer electronics, mechanical, electrical, and even, computer science engineering is working together. And you are able to see that a single flag programmed by these kids deported, the Alexa skill is deployed here, and then you are able to talk to this. And not just one, but look at it. All the flags are now responding to one Alexa device because it is connected to internet, IoT. All these flags are Internet of Things flags basically. So this is, is what is the overall thing. You can build chatbots for connecting. You can program this hardware using Python, or you can program this using web apps. And then essentially, all of this is open for these kids to learn at a very, very young age, right? Very, very young age, essentially. And that is what we are doing as a part of this. And then you can even do machine learning also as a part of these models, actually. So, all of this, all I wanted to say is that even if you are an electronics engineer, you have to know about other branches. But if you go for computer science and only say that I know computer science, believe me, as a part of a company, doesn't work for me. I expect people as a person from a company to know their branch in detail. As I said, right, if you are a batsman, be very good in batting, but you should know, how to field, how to be a team player, how to understand the situation, and how to complement the captain's fielding policies if I'm a good bowler, or how to analyze a pitch and then play accordingly. If the other side of the batsman is in aggressive mood, just take a single and give him the strike. All of this is part and parcel of teamwork in the world of cricket, which actually helps you to win matches. The same expectation is there in a case of company, wherein all engineering disciplines and values and everything comes together. Very, very important. And all those things is what I typically look at. And then this part, which I wanted to show you. So if you look at this, it has got the processors, a lot of cloud components. Then it has got Amazon Alexa and Dialogflow. It has got Fritzing, which is electronics engineering software, Autodesk Eagle for PCB designing, Fusion and 360 for CAD designing from mechanical. We use Google and Zoom Meet as a part of interaction with the kids. Then we have the Arduino world. Then we have the web framework with HTML, CSS, JavaScript. And then all the UX design happens in Adobe tools. So the video which I have shown you is made using video creation editing tools, that is After Effects, Premiere Pro, and Media Encoder. So I have experts in this field in my team. I have Photoshop experts and Illustrator experts, and whatever you are able to see on our website is done using the visual design. So it depends, like everyone has a role to play. If you say that computer science is the only branch, believe me, you will struggle in your life like anything. If you learn mechanical, you can still learn computer science. But if you have only learned computer science and did not go and learn the fundamental branches of electrical and mechanical, even electronics is also an applied branch, it becomes very difficult, I'm telling you. Because just a computer science engineer, I am from a company, I will tell you, unless you have the knowledge of applying that to the electronics world, mechanical world, I may not be able to look at you as a potential candidate who can be recruited actually. And that is what is a key this entire stack talks about, that every special point here represents a person behind the scene, and all of them work together, and I have to understand all this together. That's where you grow as a big person, right? Otherwise it's not going to work out. Just you, if you put the only vision of becoming a computer science engineer, it is not going to work out for you. And on this together, using 20 programming languages, 1 million line of code is getting executed, and we understand where there is a mistake and how to troubleshoot in real time. So all of this works together. Another glimpse of the architecture aspect of it is here. That is how these things interconnect. That was a technology stack, but here is the actual glimpse of an architecture, how these things are interconnected and how they work. Some parts are on cloud, some parts are on the user side, and some parts are under Dockers and all of that. And then you can see Google AI also being consumed here, and then some RabbitMQ messages and all that. So don't worry, but you see WhatsApp here. So WhatsApp is also integrated. So all of this is part and parcel of the design, and that's how this thing actually works together. And then I was talking about the number of lines of codes and the number of files. So you can clearly see, right, 2,859 files. Actual lines of code is 7,27,029. Then the comments, very, very important to increase the readability. So if you are a good programmer, you must include a lot of comments. You have to leave blanks. Why? Because otherwise I will not understand this piece of code is different from this piece of code and this piece of code. So a lot of blanks are also there, and together it represents 8,83,695 lines of code written in 20 languages, actually 20 programming languages. Essentially you can see Python initially, but afterwards you will be able to see the other programming languages also. So wherever I will be able to stop, you will be able to see multiple programming languages and the data formats in this. So all of this works together, and this actually becomes a single entity for us. And you can see that this hardware is in action, because everything works perfectly together as a combination of electrical, electronics, mechanical, and computer science, and beyond that, to make things happen. Okay, so that's it. Students, parents, from my side. I hope I was able to give a bit of idea of what should be the approach when we think about, doing these things, and while you are entering into engineering, what kind of expectations industry people have. And I was representing the industry part of it, and I'm trying to give you a chance that, do your best, collaborate with all departments within DSU. It is a real good place. And, even my daughter is a part of DSU. So, it makes a lot more sense for me also to say this. So I'm not just trying to say this for the sake of saying, but even, the other way around as well. Okay. So thank you so much for this opportunity, Vice Chancellor sir and Shinde sir. And happy to, be a part of these discussions always.
Thank you so much, Mr. Pankaj Bande. It is wonderful to see the way you have integrated and the multidisciplinary approach that is the signal that actually comes from your side. Thank you so much. Thank you so much. I would now, in the way the students have seen the multidisciplinary approach, even when it comes to the electronics and communication engineering, similarly, we would now like to move on and see how the mechanical engineering with the multidisciplinary approach or with the new age specializations will keep the students on the top. I'd like to invite Professor Dr. Vinayak Hemedri sir to talk about the mechanical engineering and the new age specialization along with the multidisciplinary approach. Over to you, sir.
Thank you, sir. Thanks a lot. Thank you, Mr. Shinde. Let me share my screen. Yeah. Is it visible and I'm audible, I think. I'll go to
Yes,
screen
sir.
sharing mode,
Yes, sir.
presentation mode. Yeah. 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 I'll go back to the first slide. Yeah. Good evening, all of you. I would like to welcome all the aspirants for Uniguage, students as well as parents. It's really my pleasure to take you to Department of Mechanical Engineering, what we are doing and what we are planning to do, and how a mechanical engineering department from Dayanand Sagar University School of Engineering helps students in for holistic growth of the students, how it leads to the holistic growth of the students. This is very, very important. So Department of Mechanical Engineering, if you want to define Department of Mechanical Engineering with the Dayanand Sagar University, we can define it as a department, vibrant department, which is striving for the overall growth of the student during his stay. The student stays in a university or higher educational institute for 4 years. His stay is very, very important. He dedicates his time, a valuable time with us. And we have to nurture for his overall growth. That is the whole intention, whole vision of the department as well as the university. His stay should lead to its overall growth, which leads to the good professional in the multidisciplinary area, as highlighted by other speakers. It should lead to a multidisciplinary technical person with the multidisciplinary skills. And what are the programs we are offering as far as the Department of Mechanical Engineering is concerned? You can have a look into this quickly. Okay, and I have highlighted the two words here: the vibrant department and overall growth. These are very, very important. How a student can make his stay a vibrant one, and how it leads to the overall growth. That is very, very important. And there are some ingredients to this. There are some factors that those are responsible for a vibrant department and the overall growth. A holistic growth of the student. The first and the most important factor is the curriculum. My predecessors have already covered the major portion of the curriculum, and what I would like to highlight is that we follow very meticulously outcome-based education. What do you mean by outcome-based education? Every program of study has certain courses. When a student completes a course, he should get some knowledge component and he should get some skill component. As far as Department of Mechanical Engineering is concerned, from every course, a student gets a skill component as well as a knowledge component, and that will be measured in terms of the outcome of the course. Okay, and we have a very fixed methodology for measuring the outcomes. A very stringent methodology, proven methodology. In terms of CIA, in terms of assessment, in terms of internships, in terms of projects. So we have a lot of things, a lot of components to add upon, so that outcome-based education is very religiously followed. This is very, very important. And apart from this, a very important thing is that I'd like to highlight upon What are the broad areas of mechanical engineering? Mechanical engineering, what I mean to say, is the wonderful branch of engineering. The whole lot of mechanical subjects can be categorized into the following categories: the design and the material based. There are the few subjects which are quoted under this particular category. Material science, solid mechanics, engineering, machine design, and engineering graphics. You see the importance of material science. You can see, just 20 years before or 50 years before, if you see, flying a direct flight from Bombay to, New York is highly impossible. It is, the material invention, it has led to a lighter weight materials with the same quality of strength. Now the modern flights in a single fueling can fly from Mumbai or Bombay to, or Bangalore, you can say, from Bangalore to New York directly. This is the beauty of material science engineering. And design engineering, in order to take that load, huge load, and it flies cruises at a speed of around 800 kilometers per hour at an altitude of around 10.3 kilometers or 10 kilometers. It is a marvel, how this particular system is being designed. Machine design helps in this. The gas turbine, and other things which are used and as a component which give structural load to that particular thing. And how does a system can take care of this? This is very, very important. So this is being studied in material science. And as far as, computer science application of material science is concerned, 10, 15 years back, I was using a computer, a HCL computer that was weighing around 5 kgs. Whenever I used to, on it during summers, it used to stall like anything. Within no time, it used to stall because the amount of heat it used to carry, or it used to generate when it is operating. That is the most annoying thing at that time. Now as days pass, now systems are available at very lighter weight, and hence heat carrying capacity has reduced. Its heat generation capacity has reduced. In a single battery charge, it has, it will give 4 hours, 5 hours, operation of that particular machine. So this is about the material science and design related issues. And then come to the thermal engineering, a wonderful branch of engineering. Thermodynamics, applied thermal engineering, fluid mechanics, heat transfer, refrigeration, and air conditioning. These are wonderful subjects. When you go through these subjects, you think like a philosopher. You think like a philosopher and you act like a technical person. This is the beauty of this subject. Thermodynamics, basically, it lays the foundation for energy conversion, the electricity, what we are getting by any mode. It can be direct coal burning, it can be renewable energy mode, it can be a gas-based power generation. How you produce, thermodynamic lays the foundation. The restriction, what others spoke and what, others going to speak. Everything is controlled and everything is dictated by Carnot efficiency. Carnot set a limit that this is the maximum efficiency that a particular engine or particular device can operate. And we are operating at a much lower level. In order to bridge this gap, the engineer is playing its role. Complete engineering, what I mean to say, whether it can be computer science, whether it can be electronics and computer science engineering, any optimization, what we are going to inculcate, what we are going to introduce in our system, that bridges the gap what Carnot has set and what we are operating at present. So keeping this in mind, thermal engineering is very, very important subject which lays the foundation for energy conversion. And next comes the manufacturing and industrial automation. Every system is to be manufactured. It should be present physically. Then only its importance is available. Or otherwise, if it is like, in a evaporative state, then it is of no use. Every system, just now Pankaj sir was mentioning how they were integrated a circuit. Okay, so that is a physical entity. It is a manufacturing process. Different components, a fabrication process. Different components have been grouped together and it forms as a single entity, functional entity. So keeping this in mind, your car you can take the example of a gas turbine, you can take the example of a steel plant, or you can take the example of some refrigerator. Anything in this world should be manufactured either component-wise, later it can be integrated as a single entity. So keeping this in mind, these are all the broad areas what a student covers during his stay. And apart from this, we impart special topics which cater to the project-based learning. As others also mentioned, the flexible CIAs, continual internal assessment. The flexibility in the sense a student can go for an internship, he can go for assignment, he can go for what I can say reflection notes, and a lot of components are being inbuilt in that, so that as per the convenience and as per the interest, a student can select any particular component, and it leads to a flexible what I can say assessment system. And industry internship and reflection notes I have mentioned already. And the project phase 1, as we have 2 project phases in the 7th semester and 8th semester, that students should come up with a physical model of a particular creativity, and it leads to overall growth of the student. Very common with other students. And I would like to highlight how we are different from other universities. What is the differentiator as far as mechanical engineering is concerned? As we know, and as we move upon, okay, as rightly mentioned by Mr. Sinde, there are some specialization courses what Department of Mechanical Engineering offers as elective courses. So I'll just go on, showing the different specialization. The first specialization is robotic engineering. Robotic engineering is a very, very important branch, emerging branch of engineering, wherein automation is playing very, very important role. It has reduced, industrial fatigue. Fatigue means when a person does a continuous work, he is under fatigue. His chances of committing a mistake is too much. Okay, so in order to reduce the fatigue, robotics have played a very, very important role. It has, improved the reduced history and improved productivity. Ultimate and very important thing is that it has improved the productivity. And by introducing robotics into mechanical engineering, what we are doing is that we are introducing, or we are welcoming the computer science into our domain. The subjects like artificial intelligence and machine learning, and robot vision also, uses computer science based principles and subject their utility into mechanical engineering. Hence, as we others also mentioned, that interdisciplinary nature of the engineering course is, very rightly proved here. And next comes the advanced manufacturing. Advanced manufacturing, as we know, automation is playing a very, very important role. The use of robots, that is one of the important things. You must have seen, car assembly line, in which now human intervention is very minimal. Just he programs and he goes for a coffee. Complete car assembly is done. It has been, done through robotics, done through robots. And all big industry lines, machine shop lines controlled by robots only. And apart from that, if you go into devices which actually do advanced manufacturing, CNC, computer numerical control, NC machines, hydraulic drives, and pneumatic drives play a very, very important role in advanced manufacturing. And all these things are taken into account. A second specialization course, which is intended for students to enhance his knowledge and professional skills, is advanced manufacturing. And next comes the green energy systems. As we are aware that we are going more towards energy intense society. And energy is our comfort level. We cannot compromise on our comfort. Not even for a single minute. We cannot use our mobiles. And we want refrigerators, ACs to be on always. We want a mobility for us in order to reduce our other area, in order to reach a particular point of location at a swifter interval of time. So this energy intense society, and it has led? It has led to a very common problem called as pollution. You must have heard of global warming. You must have heard of acid rain. You must have heard of ozone depletion potential. And these things, and even this corona also, the pandemic also, it has all because of the human activity, what we have done over the period, callous activity, what I mean to say, a callous activity, what human being has carried out over the period of time. In order to reduce this, in order to reduce the footprint, whenever we go in bit of the panther, generally people say, what you left after when you leave the earth. The thing what we leave is our carbon footprint. But how much do you leave? You should leave very minimal. That is very, very important. So green energy systems gives a broader idea, broader vision of how power or energy can be generated in a greener way and how it can be utilized in an optimal way. So these are some of the important concepts as far as green energy systems are concerned. And apart from this, emerging automotive technologies, as it's a very buzzword like e-mobility, electrical mobility is playing a very, very important role as far as controlling the local pollution is concerned. As far as electricity is generated through renewable energy mode, the one of the fullest way of meeting the mobility requirement. Okay, so hybrid electrical vehicle system, automotive transmission, you must have heard of CVT, continuously variable transmission, hybrid transmission using epicyclic gear train, automotive electrical systems. So very, very important as far as a mechanical engineering student is concerned, so that he can enter huge domain, a very big horizon, and the students also. So this is keeping all these things in mind. We have categorized the specializations into robotic engineering, advanced manufacturing, green energy systems, and emerging automotive technologies. Just to cater to the requirement of the student as for the latest requirements. And as others also highlighted, I'll not be discussing much on minor degree programs. If you join us as a mechanical engineering student, while you graduate, you can become a double degree holder with a minor degree in computer science, with minor degree in electronics and communication engineering, or with minor degree in aerospace engineering. Okay, so this is very differentiator as far as the Dayanand Sagar University is concerned. And you have to cover, even Professor Srinivas also mentioned that you have to cover 18 to 20 credits prescribed by that particular department, and that is taken care well. Okay, so this is about the specializations. Okay, this specialization is well within the limits of our credit limits of the department, and minor degree program, just add 18 to 20 credits to that and you will earn a minor degree. This is what I can tell you. Okay, then other very important ingredient is experienced faculty, both from industry and academia. All the faculties are PhD from reputed institutes. You just please go to our website and look into that. And a lot of industry exposure. Our faculty pool is blend of academia and industry people, and research and innovation centric approach. All faculties take student to a point where they can think of innovation. And adjunct faculty is very, very important. We have pool of very eminent learned adjunct faculty. As and when system demands, as and when a curriculum demands, as and when in a semester student demand is there, we call our adjunct faculty to deliver what is actually happening in the industry, what is actually required for them. This is the beauty of the faculty. And all the faculties are research oriented. They are having good amount of projects with them. This is very, very important. Okay, and apart from them, the other important factor that is very, very responsible for the growth is the infrastructure. Dayanand Sagar University has invested a lot, and it has given state-of-the-art infrastructure to cater to all academic labs. You can see the academic labs available with us. Just now, Professor Mr. Pankaj was mentioning Autodesk Fusion. Engineering, graphics, and design in the first year itself, we use Fusion 360, 3D modeling. Autodesk for 3D modeling. Okay, this is how we cater to the requirement. We know the nerve of the industry, what industry demands. Okay, that we know. Catering to the need, in the first year itself, in the basic engineering, graphics, and design, we have introduced Autodesk Fusion 360, and our students are very good at. Okay, these are all some of the academic labs at par with IITs, at par with any very, very renowned universities. We have the lab facilities, and this is very common. Apart from this, what I would like to highlight, apart from this, what is special with us as far as infrastructure is concerned? And of course, it has been mentioned in the initial video run by Mr. Sindhe also, that innovative campus, the Autodesk Center of Competence. Even Pankaj sir is mentioning Fusion 360. We have, the Autodesk investing crores of rupees with us, and state-of-the-art facility for CAD modeling using Autodesk as well as Fusion 360, and whole lot of suits. You can go for architectural suit, you can go for a building suit, and you can go for a inventor suit, you can go for a Fusion 360, whatever required. All the suits are available, all the softwares are running for your requirement. And you can see some of the projects. This tractor is being conceived. This is the CAD model with our lab. Then it is being analyzed with the ANSYS software. And then these are the what you can say 3D printed. Okay, 3D printed models of some of the creative drawings by our students. Just to add feather to a cap, I would like to highlight what our students have done by using the facilities of this lab. Okay, just it was a very recent event, and I feel very proud to discuss with you. This was the competition conducted or held by Autodesk India, the design tinkering challenge. Okay, just to tinker, just to fine tune the students. It is held very recently, completed last week only. Okay, just you can see here in this particular challenge, this is the group of students from our department. The team name is Cadistic. The team name is Cadistic, and these are all the students who have participated in this particular event. And what they have done is simply amazing. You will go mad. Just see. This is a robot, disaster management robot. Industry people welcomed it like anything. A student who has undergone a Fusion 360 course, and then he has worked in the Autodesk lab, and what he has done, just see, imagine the invention, the creativity. Even Honorable Vice Chancellor has highlighted the creative thinking. It is the ultimate. This is the limit for creativity. He has incorporated a camera into this. He has incorporated, some life-saving device into that. He has incorporated so many drives into that, and the student group has come with a device which is of great utility when, as far as human being, entry to that particular region is highly impossible, and a robot can enter there and it can do a marvel there. Just see, marvelous, the way the drawing is being presented, the way the bill of materials is being presented, the way entire thing is done. Industry people were mesmerized by this. Right now we are in a position, we are planning for a 3D model of this, so that functional aspects can be invoked into this, and we can introduce it in the market. This is the near future requirement from our Autodesk lab, so that even yesterday students have approached me, sir, shall we come to the college and shall we continue with this project? So with this particular invention, with this particular creativity, the students have bagged first prize for this, and they have won 10,000 rupees cash prize. Just imagine what it has led, from a basic knowledge of Autodesk to a product, generation of a product, developing a product. It is what required, and we equip our students with these set of skills so that he can compete. Pankaj sir can easily take him in his lab, because he is having that skill set. The skill set is available with him. So this is the beauty of what we inculcate, what we tell, what we introduce, the skill sets in our students. This is very, very important. And apart from this, we have automation lab. I spoke of robotics. I spoke of so many automation things, robotic arm and other things. And you must have seen the BMT buses operating with pneumatics, the landing gear of aerospace. All these things can be simulated using a automation lab, which uses hydraulics and pneumatic facilities, sensors, PLC programs, and all these things. Student, depending upon his interest, he can go to Autodesk facility, he can come to, the facility of the automation, and you can earn some credits through that. He can earn some certificates to that. He can add value to his CV. This is very, very important and very, very holistic. And apart from this, I just move very quickly. As far as other important aspect is concerned, we have very vibrant student clubs. We have cultural clubs, music, arts, photography and other things. We have a very, very important student club, collegiate club, college-based club on SAE. SAE stands for Society of Automotive Engineers. Is one of the world's reputed body which conducts or which caters to the need of mobility engineers. You can take researchers, you can take entrepreneurs, you can take philanthropists. Ford was the member of SAE. And students, academicians, researchers are the members of this body. And our students are privileged to interact with all these people. Our students are privileged to interact with all these people. And, industry specific, these are the competition available for our students to participate. And in number of competitions, our students have participated. One of such competition is Tiffan. I'm going to discuss it briefly. Okay, so this is Tiffan. In the previous events, our students have participated. You can see Technology Innovation Forum for Agricultural Nurturing, a societal impact based project. And you can see a tractor, I was showing in my earlier slide also, a tractor is being developed, fabricated by our students, then it is being field tested in Rahuri, where National Agricultural College is there, very big agricultural college where this event was conducted. This is for onion harvesting. This particular tractor and articulated arrangement is for onion harvesting, and our students have won 20,000 cash prize for best marketing category, under best marketing category. This is the team. They're all placed with very good companies. The guy who is with the white t-shirt is with Continental, and this girl is with some European country with some company. All are placed in very, very good companies. This is how the overall growth, the team leadership, managing a team, managing the finance, is very, very important. This complete project is around 5 to 6 lakhs, and students have managed it. Students have managed, and very importantly, Dayanand Sagar University has funded this particular project, and we should be grateful to the management. Management supports these kind of activities. This is what I would like to highlight. And next, we move to very important other clubs also. ISRE is there, student club, Indian Society for Heating, Ventilating and Air Conditioning Engineers. Very, very important. It helps our students in job prospects also. Material and Manufacturing Science Club. A lot of, as I told you, importance of material science, the inventions. A very, very, emerging branch of engineering is material science. Okay. There is no end to this. Every day there is a newer material. There is every day a better material is being invented. So this is the importance of club, wherein you can discuss the future.
Professor Viraj, as we have time limitations.
This is my last slide. This is my last slide. This is my last slide. So and you can see that when a student undergoes all these things, you can see he is ready for all these things. He is ready as a design engineer. Can you imagine? He is ready as a production engineer. He is ready as a maintenance engineer. He is ready as a planning engineer, and he is ready as a sales and marketing executives. Because of this, you can see the placements with our students. You can see name many big company, everything is available. Continental, the world leader, the Quest Globe, okay, Toyota, Tegutech. Very recently 2 students have been appointed. Hyundai Motors. So these are some of the companies where our students are being placed, and they are doing really good. So with this, I'll conclude, as time is a restriction, and we strive for quality and excellence in academics. This is Dr. Vinayak Hemadri, the Chairman, Department of Mechanical Engineering. I, like you people approach me for your any queries or any admission related or any career related issues. I'll be pleased to answer you. Thank you. Thanks a lot.
Thank you so much, sir.
Yeah.
Thank you so much, sir.
Yes, sir.
The event of time, I would like to request Dr. M.S. Rajamurthy to please take over and give us the complete idea about the specializations under the aerospace engineering. Sir, we have over 10 minutes. We have another webinar immediately after this. Over to you, sir. Sir, you're on mute, sir. Dr. M.S. Rajamurthy, sir. Dr. M.S. Rajamurthy, sir.
Yeah. I'm
Yes,
coming.
sir. Yes, sir. Please go ahead with the screen sharing. We have about 10 minutes, sir.
Yeah.
So, are you there with us?
Just a minute, please.
Yes, sir.
He's there. Yeah. So that's
Is the screen visible? Please go ahead.
Yeah. Good evening, my dear young friends. I see about 30 students waiting for this. So I'm sure you are really interested in aerospace engineering. With this short duration of 10 minutes, I've just run through some of the basics as to what is aerospace engineering and what is this career in aerospace engineering is able to give you. In the sense, there are two things. First, I'm going to cover the basic discipline and then tell what kind of facilities are available, particularly this Dayanand Sagar University for aerospace engineer training, and also what are the job opportunities and the career opportunities that are possible with aerospace engineering. Aerospace engineering deals with the development of aircraft and spacecraft and associated engineering systems. Aerospace engineering and the other disciplines is highly interdisciplinary. It is a confluence of the basic engineering disciplines, mechanical, structural engineering, electrical, electronics, communications, computers, chemical and material sciences. Development in any of the basic engineering disciplines has a great impact on aerospace engineering because it is always looking around and assimilates any of the new things that are developed to make a better aircraft or spacecraft. Some simple definitions here. Aircraft is any machine or weight-carrying device that is designed to support by the air, either by buoyancy or by dynamic action. So we have two types of things, where one is the aerodyne, where the dynamic action of flow of air over the surfaces produces the lift for it to sustain in flight. In the other case, you are using the buoyancy effects to produce. The two aerodynes that are most popular are the airplanes and helicopters, as you see here. And as you can see in this picture, you have a huge spectrum of these aircrafts. You can talk about a 10-ton aircraft, which is flying at supersonic speeds, to a giant jumbo, the A380, which is about 500 tons of weight, carrying about 600 passengers across the globe. So that is the spectrum of vehicles the airplanes have been covering, and people have designed these things over a period. And also there are certain unique features that are developed in these aircraft. For example, here you can see very uniquely appearing aircrafts. These are all developed mainly to transport huge components of aircrafts from one place to other to assemble them at another location. Here are the aerodynes. Here, these are very unique aerodynes are the aircraft which has the ability to hover around a place. For example, the Sikorsky, who was one of the great designers of helicopters, always said that when you're an aircraft, you can just go over a place and shower the flowers on the place. Whereas in case of a helicopter, you are able to stand at that particular location and rescue the guys below. So that's the unique feature of the helicopters. So also the vehicles which are part of the aircraft community, which use buoyancy effects, mainly using the lighter than air gases. And here you see two examples of blimps which are of the contemporary design, which are using helium. So then we have the whole plethora of vehicles called unmanned air vehicles, which is the new technology that is there, where you remotely operate vehicles without a man there, getting its own advantages. And here are two examples I have shown of the unmanned air vehicles. And of course, when it comes to space engineering, it's all about rockets, launch vehicles. We have to put satellites or spacecraft into the orbit, into the Earth orbit, or to an orbit, or we have to send it across to on some missions. And here I've essentially shown the two things, mainly the launch vehicle as well as one of the new vehicles that are being developed by ISRO called the reusable launch vehicle, which is much like the space shuttle of the US. Now, by virtue of the human ability to take up new challenges, the space engineering has moved away from the government organizations to private organizations as well. I'm sure most of you have seen this video, the successful suborbital travel that was carried out by Virgin Galactic very recently, and most of you have seen the videos where one of our own Indian engineers participated. Why I've shown all these things is to just show that the spectrum that aerospace engineering covers is pretty wide and very unique. And each of these platforms, each of the aircraft that we design and built has very unique properties using multidisciplinary techniques embedded into one platform, which is capable of doing a particular action or a mission that is required to be done. Here, just to show how complex the aeronautics development could be, I have taken this example of light combat aircraft designed by Indians. It is called the Tejas, which most of you would have seen the videos, you would have seen in the Aero India programs, and also in some demonstrations. Here, for building this aircraft, you can see various centers across our country. That shows how multidisciplinary it is. So, in building a complex system, combat aircraft, you see the participation of so many organizations of different kinds. You can see the academicians getting involved, the people from the electronics community, people from mechanical communities. So many components are being developed from different places. That's how complex a given aircraft is. So just coming back to what you can do in aerospace engineering, specifically focusing on what are the things that are available at the Dynamics Agro University. I see that the aerospace engineering department has a faculty with a very wide experience, both in industry as well as in the R&D labs. Plus, they have a unique aerospace center of excellence in technology partnership with Dassault Systems, which is the French company which makes the Viraj 2000 aircrafts. And they're establishing a state-of-the-art laboratories for skill development in various sub-disciplines, namely the product development and design and development, flight physics validation, of course, avionics is a very important thing in the aircrafts, reality, aircraft systems, aerospace structural design and composites. And through this center of excellence, they are also establishing links with the industry so that the students get an exposure to the contemporary technology and is able to do some project work, and he also is able to understand processes and he gets exposed to it. In this aerospace engineering course, we're essentially covering some basic courses called the aerodynamics, which is essentially talking about shaping the aircraft so that he is able to generate the aerodynamic forces that are required to fly. Aircraft structures which are very light and at the same time they are having appropriate strength. Then we talk about propulsion, we talk about the various engines that are there, jet engines, propeller engines, and we talk about aircraft systems, which forms the brain of the aircraft development. So the contemporary designs, the development in electronics and the power engineering has dramatically changed the aircraft systems. Then we have the control and guidance. And of course, aircrafts keep demanding specialized materials to be developed, which are essentially strong, able to withstand higher temperatures, because we are talking about higher speeds also. And of course, you are introduced also to the space sciences. When a student does his basic degree in aerospace engineering and he would like to get into research, there are a lot of possibilities in our own country. We have world famous institutes, Indian Institute of Science, all the 4 IITs, Bombay, Madras, Kanpur and Kharagpur, and the Institute of Space Technology at Trivandrum, handled by ISRO. Plus, there are many R&D laboratories that are able to give you an opportunity to pursue aerospace research. And of course, the hot topics of aerospace research currently are the aerodynamics. We are talking about hypersonic vehicles, and then we are talking about machines where the internal flows are very important. We are talking about aerospace structures, propulsion systems, avionics, and advanced materials for aerospace applications. These are all the research domains where someone can pursue after doing his basic degree here. Of course, if someone is looking for an opportunities in aerospace engineering in terms of, okay, I show many of the aircrafts there, whether someone is interested in designing development of an aircraft, there's an opportunity here, and someone is interested in manufacturing some components of the aircraft and subsystems, there is a possibility. Then, of course, someone can work in the industry as aircraft maintenance, repair, and overall aspects. And we have a very powerful defense setup which has developed unique missile systems for our country, and one can work on these developmental programs of the missiles. And of course, ISRO has a whole plethora of launch vehicles, satellites, and spacecrafts, and they're very unique programs. As you can see here, in the next 4 years, when you're going to come out of the college with your degree, you have an opportunity to cover the whole spectrum. That's what I'm trying to show here. There's also a possibility of someone getting into the Air Force. If someone is interested in being a combat aircraft pilot or a transport aircraft pilot, still there's a possibilities of getting into these things, because you have to complement your engineering degree with certain training in the aircraft flying. So you get your pilot license, still you can be a pilot and still enjoy the aerospace. In terms of the industries that are available for thing, you can see here the Aeronautical Development Agency, which is charged with responsibilities of developing combat aircrafts. They're doing many designs. HAL is manufacturing aircrafts. Then there are the private TCS, Infosys, Wipro, and then we have the CSIR, National Aerospace, who do a lot of development work, and also they were able to do some research at these laboratories. Then they have the DRDO setup, and of course, Bangalore being the aeronautical hub of this country, most of the major players in the world centers set up here in Bangalore, and so you have a lot of opportunities to get into any of these organizations. Then looking at the civil aviation domain itself, you have so many airlines that they are operating various aircraft. There also there are a lot of possibilities for engineers to go and work. We have flight operations where you talk up. Hello? Is there an interruption?
No, sir. Continue, sir. It is audible. Very much audible.
Okay. Then we have the flight operations. See, in case of an aircraft, the safety is paramount, and one has to ensure that the aircraft is, as a machine, it is at the same time, the pilots who are going to fly the aircraft are also trained properly and they are able to handle the aircraft. So we have two kinds of quality assurances that we look in the aircraft industry, particularly the industry. We are called what's called the flight operations quality assurance. Here we monitor how the pilots are going to fly the aircraft, what are the contingencies that they face, what are the shortcomings, if there are anything. Similarly, there is the maintenance repair and overall group, which can monitor the operations of the aircraft and make sure that the aircraft is in a perfect good condition. So here is also a very interesting learning that is there, because you really coming back to the hangars. So it's a very interesting experience. In fact, to share my own experience, I worked for 32 years at the National Aerospace Laboratories as an R&D engineer. But then I spent 6 years with the Middle East airliners, where I could see the aircrafts and I could see how the operations are carried out, how the aircraft's safety is assured through using this both program called the FOCA and the MOCA. Just to give the plethora of programs that are currently going on in our country, where you people can blend into and contribute. See, already responsible for developing our Tejas aircraft are looking at advanced versions of the combat aircraft. Similarly, HAL is looking for what's called the multi-role transport aircraft. They are also developing a jet trainer aircraft, and DR with the unmanned combat aircraft called Ghatak. And similarly, HAL has developed what's called a combat air teaming vehicle called the Warrior, which is again a unmanned vehicles. And of course, ISR was their own grand program of developing a reusable launch vehicle similar to the space shuttle. They have manned missions and they also have planetary missions. These are the current programs where you can always find an opportunity to join and contribute. I'm just giving you a pictorial view of the various vehicles that are being developed here. AMCA is a advanced multi-role combat aircraft that's being developed. And you can see the other aircrafts also and the unmanned vehicles.
Sir, sorry to disturb you. There is a hard stop.
Yeah.
You'll have to stop it in 2 minutes because there's another webinar lined up immediately after this. Sir.
Okay, absolutely no problem. I'm almost coming to the end.
Right.
So here there are some new programs from HAL, and here is a program from the space department, where the launch vehicle, reusable launch vehicle is shown here. When it comes to reducing the carbon contribution footprints, aeronautics are also not very much behind. We have already developed aircrafts called more electric aircrafts, and there's already a development of what's called the all-electric airplanes. So days are not too far off when we're going to see these all-electric airplanes flying in our skies. So with this, I conclude, and my suggestion to the youngsters who are interested in aerospace engineering is a highly multidisciplinary branch where you have a lot of opportunities to do a lot of interesting things. Thank you very much.
Thank you so much, sir. To all the students, we thank you so much for attending this webinar, and we'll get back to you in an email with our DSET dates And the special dates being announced as 12th August for all the students from Uniguage, where you do not have to pay any registration fees. You can directly attend the exam. Mr. Manoj from our office will get back to you on this, and you will get astonishing scholarships if you are able to come in the merit of the DSET examinations. Thank you so much. In the interest of the time that we have another webinar, we are sorry we will have to exit immediately, but we thank you everybody for this.